Hello everyone, I welcome you all to my channel Essentials of Electronics. In today's video, we are going to discuss about a new IC555 timer. This is commonly called a timer IC, IC555 timer because it generates square pulses based on the timing intervals. So T1 and T2. Let T1 be the on time and T2 be the off time. The total time for one pulse is T. T is equal to T1 plus T2. So these pulses are generated by the IC555. Since it is mostly used for all timing circuits, it is called as timer. This is one of the most remarkable integrated circuits ever developed. It comes in a single or dual package, and even low power CMOS versions exist like ICM 7555. The common part numbers are LM555, LM556, NE555, etc. So it is a 8-pin package with the grounding, triggering, output pins, reset pin, control pins, threshold, discharge, supply pins. I will draw the block diagram of the timer IC. So these ICs are used for uh, generating square waves and hence for multi-vibrator circuits. Yes, we have two op amps, a lower op amp 1 A1 and upper op amp A2. The outputs of these operational amplifiers are fed to a flip-flop called RS flip-flop. They have outputs Q and Q bar. In order to show the pin detail clearly, these are the basic things, and I will complete drawing the circuit diagram. It has a BJT as well, or in the value. Now, this is the internal block diagram of a timer IC, which has three resistors which are acting as a voltage divider part, which gives a constant voltage. It is fixed at pin 8. The first pin is the voltage divider part. The second pin is the trigger terminal, which is given to the inverting terminal of the op amp. 5 and 6 are the control threshold terminals, which are given to the operational amplifier 2. The seventh pin is the discharge pin, which is the collector terminal of the transistor. All the three values of resistors are the same, and the output is collected across the third terminal. A reset pin at the fourth terminal. So this is the 8-pin diagram of a timer IC. It has three equal values of resistors. It divides the input voltage VCC into three equal parts. The two comparators and the op amps that compare the voltages at their inputs and saturate depending upon whichever is greater. The threshold comparator saturates when the voltage at the threshold pin 6 is greater than 2/3 of VCC. It will saturate when it is 2/3 of VCC, and the trigger comparator saturates when the voltage at the trigger pin is less than 1/3 of VCC. The flip-flop is a stable, bistable device. It generates two values. One is a high value equal to VCC and a low value equal to 0. When the threshold comparator saturates, the flip-flop is reset and its output is a low signal at P. Pin 3, it is a low signal. It is a low signal. When the trigger comparator saturates, the flip-flop is set to yes and it outputs a high signal at pin 3. The transistor is being used as a switch. It connects the pin to ground when it is closed. When Q is low, Q bar is high. This closes the transistor switch and attaches pin 7 to the ground. When Q is high, Q bar is low. This opens the switch and the pin 7 is no longer grounded. So with these basic features of the timer, it is applied in precision timing, pulse generation, sequential timing, time delay generation, etc. For pulse width modulations, these timer circuits are widely used. We have some applications of timer which will be behaving, other basic applications, it will be behaving as multi-vibrator circuits. Behaves as multi-vibrator circuits. The different types of multi-vibrator circuits are astable multi-vibrator and monostable multi-vibrator, which we will be discussing now. The first kind of multi-vibrator, we will be now using the same block diagram to understand an astable multi-vibrator using IC 555. Yes, so the internal diagram of IC 555 we have seen. So this IC 555 timer, how it is being applied or used as a stable multi-vibrator, that we will be discussing now. So taking the sixth pin and the second pin, we have a small extension of this with the two more resistors connected, and the seventh pin, two more resistors connected in this manner. The biasing of these two more resistors are connected to the seventh terminal, and the other end of these resistors are connected to a capacitor. Capacitor is grounded. So this resistor is R1 resistor, R2 resistor, and a capacitor C. This is the extension of IC 555 timer as a stable pulse train generator. This is simply behaving, it will behave as an oscillator. Here too, we are not giving any input voltage. This unstable multivibrator generates a continuous stream of rectangular off and on pulses that switch between two voltage levels. The frequency of the pulses and their duty cycle are dependent upon the RC network values. The capacitor C charges through the series resistors R1 and R2 with a time constant of R1 plus R2 into C. The capacitor discharges through R2 with a time constant of R2 into C. So now the total discharge tau is equal to R1 plus R2 into C1, and the time taken for the discharge is T1 is equal to 0.693 times of R1 plus R2 into C1. Hence, this kind of a stable multivibrator is used in flashing LEDs, pulse width modulation, pulse position modulation, periodic timers, etc. So this kind of a stable multivibrator produces continuous pulses. So when the voltage VCC is lesser than one third, lower operational amplifier will be activated and the flip-flop is set. When the flip-flop is set, Q is high. So an output is generated during that time. So by continuously giving triggering pulses to the operational amplifiers, a train of pulses is generated by the stable multivibrator and the capacitor discharges to the ground. Yes, this is about a stable multivibrator. Now using the same diagram, I am going to just redraw this and convert it into monostable multivibrator. So now we are going to discuss about monostable multivibrator using IC555 timer. The small modification of this is the plus VCC. Earlier we had two resistor. Now we will be having one resistor connected to the capacitor part like this. And the sixth terminal, the input of this goes from the divider biasing. The second terminal being the triggering pulse. This is the diagram of monostable multivibrator using IC555 timer. So here using the when the value of the biasing resistor value varies and depending on the pulse triggering of one third of VCC, the flip flop is set and a single pulse is generated and maintained at a particular value of plus VCC. And when the op amp gets a triggering pulse of two-thirds of VCC, operational amplifier A2 resets the flip-flop and Q will be low and Q bar will be high. During that time, the output will be like this. So, because of this, the monostable multivibrator is capable of giving only a single shot of pulse. The time constant for this resistor capacitor combination determines the length of the pulse. So it is used to generate a clean pulse of correct height and duration for a digital time. This is also used to turn circuits of external components on and off for a specific length of time. It is used to generate delays. They can also be cascaded to create a variety of sequential timing pulses. These pulses can allow us to time and sequence a number of related operations. This is about monostable multivibrator. So in this video, we have discussed the internal block diagram of IC555 timer and its main applications of how it is made to operate as a stable multivibrator and monostable multivibrator. Thank you.